Nestled in the rolling hills of southern Indiana, along the banks of the Ohio River, the small community of Charlestown lay situated just upriver of Louisville, Kentucky. Much like the rest of the country during the late 1930s, Charlestown was suffering the effects of the Great Depression. And if that wasn't enough to have to deal with, the winter of 1937 brought with it the worst flood ever experienced in the Ohio River Valley. Flooding drove residents along both sides of the river from their homes and inundated the land for miles. The small town lifestyle was prevalent in Charlestown, and the community boasted 2 restaurants, 1 bank, 1 post office, a tavern, a dry goods store, a couple of gas stations, and a population of 939. The world was at war in 1939, but full American involvement was still a few years off. The German advancement through Europe was disturbing and expanding in scope. The Third Reich, Hitler, Luftwaffe, and other names were entering into the American vocabulary whether we wanted them to or not. With growing concerns of global involvement, the United States began to evaluate the lack of munitions and war supplies remaining from World War I. A devastating fire in 1924 had burned the old Hickory Ordnance powder factory in Nashville, Tennessee to the ground. A loss of 50 million pounds of smokeless powder and $80 million worth of machinery and buildings. In late 1939, a real estate agent named C.V. Atwell from Wilmington, Delaware, was causing a great deal of speculation and excitement throughout Clark County, Indiana. His wanderings through the fields and farms along the Ohio River were followed with options to purchase more than 6,000 acres of land. His efforts and offers were received excitedly by most, but refused by some. In a time of shortages in both food and jobs, any offer had to be considered. However, Atwell's lack of details about who he was working for and why so much land was being purchased left residents and the media to guess and wonder. One such guess was that the DuPont Company was going to build a rayon factory to manufacture an artificial silk product called nylon. Now, it was true that the DuPont Company had discovered how to manufacture nylon in 1935, the first truly synthetic fiber ever developed, and they invented Teflon in 1938. But a much more important item that was manufactured by DuPont was of interest to the federal government on the eve of war. In 1800, Eleuthère Irene DuPont, a young chemist, came to America to escape political and social upheavals in his native France. He built a small mill on Brandywine Creek, near Wilmington, Delaware in 1802, and began the manufacture of black powder. The DuPont powder was of a higher quality than other available products, and he was soon supplying explosives for the military during the War of 1812. The company's growth included the manufacture of soda powder and a new industrial explosive called dynamite. By 1894, the first DuPont smokeless sporting powder went into commercial production, and with greater experience in a product called nitrocellulose, the company began to move more and more into manufacturing of chemical products. However, DuPont retained the industry lead in smokeless powder manufacture, and the company produced 1.5 billion pounds of explosives for the World War I Allies. With the fall of France, the U.S. involvement in the new war was imminent. On June 26, 1940, Congress passed the first National Defense Appropriations Act. 4 days later, they created the Munitions Project, laying the ground for the National Defense Program to authorize construction of a single-base, smokeless powder plant that would provide military charges for use in the war. All of the guessing came to an end when the media announced on July 13, 1940, that the world's largest smokeless powder plant would be built near Charlestown, Indiana. The site was selected for its proximity to the Ohio River, a steady source of the ever-important large volume of water needed for powder manufacture. There was plenty of land available, with minimal displacement of landowners. It was near a large population base. There was good access to rail lines. It had a southerly location for access to cotton, and was outside the 150-mile limit from a coastline, which would prohibit a surprise attack from the enemy. The government project, with a promise of 4,000 jobs, was a blessing that communities across the country would have welcomed to help rebound from the Depression's shortage of jobs. The United States planned to create a GOCO, or government-owned, contractor-operated plant. The Indiana Ordnance Works plant, though government-owned, was to be operated by a private contractor, the E.I. DuPont Nemours and Company. Shortly after the project announcement, job seekers from Indiana, Kentucky, and throughout the Midwest began arriving in Charlestown by the thousands. U.S. Army officer Kelly Lewis arrived in Charlestown on July 27, 1940, to oversee the arrival of construction materials and begin filling the security, carpentry, and other labor trade positions for construction of the plant. The first commanding officer of the IOW was Colonel Roswell Hardy. From August to December of 1940, employment at the plant grew from 40 to 13,400 construction and security workers. Men and women raised the population of the surrounding area beyond anyone's expectations. The growth of trailer parks in and around Charlestown grew at an alarming rate. The demand for food, gas, clean water, and even schools were hard to meet. Every hotel and boarding house within 25 miles of Charlestown was filled. Residents in the region rented out rooms in their houses, converted garages into apartments, and charged rent to park trailers and pitch tents in their yards. Some people slept in converted chicken coops, barber chairs, and even their cars. Construction workers worked 3 shifts around the clock, and as each shift ended, the roadways were immediately congested with automobiles. Highway 62 was widened, paved, and at times converted to all 4 lanes moving in one direction. A pedestrian overpass was built for rail commuters and employees parking in Charlestown to reach the plant. The Indiana Ordnance Plant was a 6-line, smokeless powder plant with organic facilities. An amazing project. Construction was completed in just 9 months. In that short period of time, 20 million bricks were laid, 170 million cubic yards of concrete poured, 12,500 tons of steel erected, 608 buildings were built, 40 miles of roads paved, and 60 miles of railroad track were laid. Production began on April 21st, 1941, 23 days ahead of schedule. At its peak of construction, 27,154 people were on the payroll.
Well, DuPont was probably one of the world's leading experts in nitration technology, and particularly as it related to gunpowder, smokeless powder. This plant was designated to be a single-base propellant plant, meaning that the propellant produced here was based on nitrocellulose as the primary energetic component. As it turned out, it was one of the largest smokeless powder plants in the world. The capacity of this plant was 24 million pounds of smokeless powder per month. That was a design capacity. Actually, during World War II, they produced typically well in excess of that amount through the war years. So it was a very large, very contemporary, modern plant based on DuPont technology for acid manufacturing and nitration and powder manufacturing. Black powder is a mixture, one of the oldest explosives known to man. It's a mixture of charcoal, sulfur, and a nitrate, usually potassium nitrate. Smokeless powder, on the other hand, is based on nitrated material that is originally inert, that is chemically reacted with nitric acid to produce an energetic material, and then there's a great deal of processing from that point on. Smokeless powder was clearly the contemporary type of propelling material for guns. It was also nitrated materials are used in high explosives. That wasn't the mission of this plant, but all propulsion for guns, small caliber, large caliber guns, rockets, is all based on nitrated cellulose and other additives, and billions and billions of pounds of this material was used throughout the war. Very first thing they needed was steam, and the first completed operations at the plant was powerhouse number 1, shortly thereafter powerhouse number 2. Tremendous amount of steam, and as a more or less a byproduct of steam production, there was electricity generated. A good deal of electrical power was used as well during manufacturing. The next series of buildings to come online was the acid manufacturing plants. There were 2 complete acid plants that both produced nitric acid and then concentrated nitric and sulfuric acid. And then the next area in the time frame in World War II was called the organics plant, where they produced primarily stabilizers. The main product out of the organics plant was diphenylamine. There were some other products that were produced in smaller quantities like nitrobenzene and so forth, but the primary purpose was to produce diphenylamine, which was not a readily available product during World War II time frame, and was an essential ingredient in smokeless powder. Of everything that occurred here, the most unique aspect of this plant was the fact that it was well planned, extraordinarily well planned, well designed, well conceived, but the actual construction of the plant is as close to a miracle as we can have in the modern age. To think that a plant of this complexity and this size was essentially, from the time they pushed the farmers' fences over until it was in operation, was 6 months, 26 weeks.
The IOW was responsible for producing smokeless powder for loading as propellant for military projectiles. The single-base smokeless powder used a base ingredient of nitrocellulose as the propellant charge, and the more volatile black powder was the ignition source of the smokeless powder. The term smokeless powder is a paradoxical misnomer. The material is actually a granulated substance, not a powder, and it is only smokeless in comparison to the very smoky black powder. Smokeless powder was adopted as the military standard during the late 19th century and is categorized as either single, double, or multiple based. The process of smokeless powder manufacture begins with shredded cotton or wood pulp, which are nitrated with mixed acids to form nitrocellulose. This material went into a blocking press where it was compressed into 69.5-pound blocks, which were then cut into smaller blocks and passed through a macaroni press, shaping the nitrocellulose into long, thin strands that were cut to various lengths. The powder was sent to a blending tower, where several batches were mixed or blended together to make a uniformly blended batch of 150,000 pounds of smokeless powder. During the peak year of 1943, the plant produced a daily average of 900,000 pounds of smokeless powder. The IOW was divided into 4 main areas. the administrative compound containing a main administrative building, telephone exchange, hospital, repair shop, cafeteria, guard headquarters, and office building. A shop and production area dominated by 6 parallel and nearly identical manufacturing lines for smokeless powder, 2 powerhouses with a total of 11 power units, 2 ammonium oxide plants, 2 nitric and sulfuric acid concentration plants, and lines A through D produced multi-perforated cannon powder, while lines E and F produced single perforated rifle powder. Both types were manufactured in a similar manner, with the difference being in the perforation and final pellet size. There was an extensive storage and shipping area containing approximately 100 above-ground magazines. Then there was the staff residential district of 19 two-story wood frame houses located on River Ridge overlooking the Ohio River. The Indiana Ordnance Works was the largest of 3 smokeless powder plants authorized in the summer of 1940 and was the only one designed to be a permanent facility. The heavy use of steel frame and brick in the building construction was very different than the other plants across the country, which were all temporary frame structures. Access to the Ohio River and the vast underground aquifer provided the large volume of water needed to keep the production facilities in operation. A revolutionary series of 7 horizontal collector wells, known as Rainy wells, created the largest single groundwater project in the world. The combined effort of the 7 wells was capable of producing 70 million gallons of water per day. Each of the Rainy wells consists of a 13-foot diameter hollow caisson extending down to bedrock, approximately 100 feet below the surface. Each well has 3 levels of perforated 8-inch lateral pipes to collect the water. The pipes extend between 1,000 and 2,000 feet in a horizontal radial pattern out into the sand and gravel near the base of the well. Originally designed by Leo Rainey in the 1920s for use in the oil drilling industry, the system greatly increased production capabilities for water as well. By extending the collector lines in a horizontal pattern, the system dramatically increases the collection surface area and improves the capacity of the system. Operation at the plant continued until the final lot of powder was packed on October 5, 1946. DuPont continued to produce ammonium nitrate in an aqueous form for agricultural purposes until March of 1950. That year, both powerhouses were leased to the Public Service Company of Indiana. The DuPont contract expired, and the Spencer Chemical Company picked up the lease for production of ammonium nitrate in the No. 2 acid area. A rather interesting side story to the IOW concerns a German spy. Simon Emil Kodel was born in Germany, came to the United States in 1906, and became a U.S. citizen in 1912. Kodel worked for the Abwehr, the German Secret Service, as a spy during World War I and World War II. He obtained membership in the American Ordnance Association by claiming to be a chemical engineer and large stockholder in several defense industries. His membership in the AOA allowed him access to government facilities such as the U.S. Arsenal in New York, Fort Moultrie in South Carolina, the Radford Ordnance Plant in Virginia, and the Indiana Ordnance Works in Charlestown, Indiana. Kodel forwarded photographs of the installations with detailed reports to the Abwehr. At the end of the war, his reports and photographs were discovered during the capture of the German Secret Service's headquarters. Kodel was convicted of conspiracy to commit espionage and sentenced to 15 years in prison. During the construction of the Indiana Ordnance Works, a second project moved from the drawing boards to reality. In order to take the smokeless powder produced in the IOW to the next step, the Hoosier Ordnance Plant started construction on February 5, 1941, and would serve as the load, assemble, and pack facility. The architectural firm of Shreve, Anderson, and Walker were contracted for the architectural work. The construction of the project was undertaken by the WHMS Construction Company, a combination of the Winston Brothers Company, C.F. Hagan & Sons, Inc., Missouri Valley Bridge and Iron Company, and the Sollitt Construction Company. And the Goodyear Tire and Rubber Company of Akron, Ohio, received the operating contract for the HOP. An additional 4,900 acres of land was purchased, adjoining the southern boundary of the IOW. This acreage included 50 farmhouses, 35 summer cottages, and the Union Cemetery. An additional 9 cemeteries can be found within the boundaries of the government property, and all were fenced off for protection and were maintained by the plant throughout its operation. This new operation of 400 buildings would manufacture and load bags for the propellant charges for artillery, cannon, mortar, and miscellaneous igniter and booster charges. The bag lines were complete and in operation by September 2, 1941. On that day, 52 charges for the 105 mm howitzer were produced. The bag house closely resembled an industrial garment factory, with hundreds of fabric cutting and sewing machines. The cotton and silk bags were cut and sewn together and sent to the loading or charging lines. The facility consisted of a small administrative compound containing an administrative building, employment building, and a hospital. There was the production, maintenance, and storage area, including 24 warehouses, a repair shop, fire station, heating plant, and a bag manufacturing building covering almost 4 acres of ground. There was the charging area, comprising 8 identical lines for bag loading of smokeless powder, and 4 identical lines for bag loading of black powder for igniters of propellant charges. An extensive powder magazine area contained 177 earth-covered, steel-reinforced concrete, barrel-shaped igloos. And then there was the staff residential district of 17 two-story wood frame houses, similar in design and adjacent to the staff residences of the Indiana Ordnance Works. In contrast to the construction of the Indiana Ordnance Works, the Hoosier Ordnance Plant was not built as a permanent facility. Construction materials were wood frame instead of steel, and clay tile and cinder block were used instead of brick. The majority of the buildings were built in a typical blowout manner, in which cinder blocks in the walls were placed so that in the event of an explosion, they would blow up and out and not demolish the entire building. The extremely large bag manufacturing building was the exception. This large of a single-story structure had to be functional, quickly built, provide logical and efficient flow from one process area to another, and it was designed to maximize the use of natural light. The sawtooth roof construction with its windows provided vast amounts of natural light for 1,000 employees. Also of importance was adequate ventilation. A system of fans provided a complete changeover of air in the building every 6 minutes. The 2 separate functions of the HOP included bag manufacture and the load, assemble, and pack process. The LAP process took smokeless powder, measured it, weighed it, placed it in a bag, and sewed it shut. Each charge consisted of a stack of up to 7 bags or increments of powder that were attached together. These were then placed in an outer charge bag, which was packed in containers for storage or shipment.
This is load line 2. There were 8 big load lines that did the charges. And this is load line 2. It's the last of the load lines that is still standing as it was used. The others has been burned to decontaminate them, but this one is still standing. It would take some rehab to get everything working, but we could operate this building. The raw powder comes in from this side, brought up on a forklift, comes into the elevator. The door would be raised open, a pallet load of propellant would go in there. They'd shut the door, and then it would take it up to the second floor, it would be dropped into hoppers for each one of the sewing rooms. And that's the powder they would load into bags. The bags would also be coming up from the other end. They'd be put in the booths, depending on what increment it was, and they would be loaded, check what weight and check weight to make sure it's exactly the right weight. Then it would go to the end of this row of booths to an assembly area where they would all be tied together, so you would end up with a full charge. It would be inspected, checked, put in a can, airtight waterproof container, and then it would be shipped down to the middle magazine where the cans would be palletized for shipment. This is an aisle, so that's not the booth. The booth starts here, and it's 1, 2, 3 doors. So that's how big the booth is. So that's probably 15, 18 feet. And from this door to the wall is probably 8 to 10 feet. And there are chutes on the wall inside there that can be raised up, charges put in it, pull the door down, the door can be opened on the other side, and the inspectors would take a look at everything and make sure it was acceptable. They have the empty bags that were made down at bag manufacturing. It's very possible if it was an igniter bag, the igniter bag would have been loaded at another operation. Then they have instructions how much powder to put in each bag. Some charges had up to 5 different bags. So the base increment would have the igniter pad, maybe a flash reducer, which potassium sulfate at the top end. And they would have an opening where they could pour the correct amount of powder in. The powder weight or assessment was given to us by JPG. They checked it and said, here's how much you need to put in this bag for this powder lot. A powder lot might be as many as 25 or 30,000 sets of bags. So that's what goes on in this operation. The next series of 3 doors is another booth, so they might load increment 1 here, increment 2 there, increment 3 next, increment 4, increment 5, and then they would go in the middle aisle inspection to the assembly area. This is the assembly area, again, in a little modification from a regular load line, but the charge would come through the chutes behind us, what we saw on the other side when we were taping, and would come through here for inspection again. They would be checking everything to make sure it's all put together the right way. It's got the lot number on it. Would come up to here, probably stenciled with the date on it, and then further down, again, quality checks, make sure everything's okay, and then it would be placed in a container, long-term storage container, airtight, waterproof storage container. From there, it would go on a conveyor down to the final palletization area. When we finished the production powder lot, there would always be a little residue. There might be a can or two, or there could be 1,000 pounds. And that had to go to the burning ground to get rid of it. The burning ground was in this area, and they would spread it out on some trays. You couldn't put it too deep. If it was 1 inch high, that was fine. If it was 3 or 4 inches high, then it would create an explosion. You would hear the boom, it would shake the windows. So the burning ground was used to get rid of the powder that was the end of shift powder or the end of lot powder that just wasn't enough to start another day's production. Interesting little story. The cleanup of the facility is just an amazing task that's going to take a tremendous number of years. I'm talking about 10, 20 years possibly. And this was one of the first areas they cleaned up. They shoveled up all the dirt and all the gravel. They sent it up to Ohio and they burned it. They burned the dirt to make sure there wasn't any contamination.
Employment at the bag plant took a slightly different turn in demographics. While the majority of employees at the IOW were men, women made up 2/3 of the staff at the bag plant. The use of so many sewing machines, the demanding accuracy needed in measuring powder, and the good eye-hand coordination required positions that were often better filled by women. The war years were a time that many women found that they could hold down gainful employment, contribute to the war effort, and help put food on the table for their families. In early March of 1942, Goodyear's employment reached its peak with 7,562 employees. Safety was always a concern throughout the plant. The chance of an explosion was always a danger. Employee safety meetings, training classes, newsletters, and other measures were always in place to maintain a safe work environment. Buildings were spaced widely apart, transfer chutes were used to reduce airborne powder, conductive soles were issued with work clothing to reduce static electricity. Emergency slides provided quick escape routes, and of course, employees were searched for matches before clocking in at the change houses. Male and female security officers were responsible for searching employees coming into work to keep out the contraband matches and lighters. While some accidents occurred throughout the years, the two most memorable ones were a blending tower fire that killed 3 people in 1944 and an igloo explosion in 1966 that also killed 3 workers. During the spring of 1945, there was a slight scaling back of production, and on VJ Day, the plant contractor terminated 5,000 production workers. The war was over, and all production ceased by August 18, 1945. The Hoosier Ordnance Plant was declared a standby facility. During December of 1944, construction began on the Indiana Ordnance Works Plant No. 2, otherwise known as the Rocket Plant. This last expansion effort of the plant added 8,300 acres to the government-owned property. The acquisition included several farms and the old Rose Island Amusement Park property on 14 Mile Creek. Once again, the DuPont Company was the architect and general contractor for the plant. The Indiana Ordnance Plant No. 2 was designed as a 3-line, double-based powder manufacturing plant for manufacturing rocket propellant. The double-based powder varies from the single-based powder in that it is comprised of a 60-40 mixture of nitrocellulose and nitroglycerin, and was used to power bazookas and other rocket weapons.
On the south side of 14 Mile Creek was the nitroglycerin plant, and a portion of the processing area for the rocket motors. On the north side was the finishing operation with the extrusion operation of the rocket grains, and then all of the storage area, the Richmond magazine area.
While the rocket plant was never actually completed, for 5 weeks it did produce about 292,700 pounds of rocket powder. The IOW No. 2 was shut down shortly after Japan's surrender on August 12, 1945. The shutdown of construction and operations was swift and immediate. Workers were notified throughout the plant by means of a truck with a loudspeaker mounted on its top. The message was loud and clear. Attention! Attention! Lay down your tools. Clock out. You will be notified when to pick up your final check. For years after the plant's closing, hammers, saws, drills, and other tools could be found lying around the various work sites. For a short time in 1945, the IOW No. 2 used almost 1,000 German prisoners of war to supplement the labor force. The captured German soldiers from Rommel's Afrika Korps were brought to the site in May 1945 and were housed in a temporary camp built on the property. They provided unskilled labor for the digging of post holes, ditches, and other manual labor activities. A temporary camp consisting of wood-framed, canvas-covered tents was constructed to house the POWs. By August, the war had ended and the prisoners were returned to Germany. During a reorganization of the plant in 1945, the military renamed the facility the Indiana Arsenal. From 1952 to 1957, DuPont and Goodyear returned to their World War II roles of powder manufacture and loading operations. Peak contractor employment was in 1953, with 8,019 employees hired and used to produce charges for the Korean conflict. During August of that year, 13,370,000 pounds of propellant was granulated, and 13,417,000 pounds were newly manufactured. In September of 1957, the last lot of cannon powder was packed and the line was shut down. While no major technological advancements occurred during this period, almost 50 new buildings had been built. DuPont and Goodyear remained under contract as caretakers of the facilities until 1959, when maintenance of all production facilities was assumed by the Liberty Powder Defense Corporation, a subsidiary of Olin Matheson Chemical Corporation. Once again, a reorganization within the military resulted in a new name for the plant. It became the Indiana Ordnance Plant on November 1st, 1961. The Vietnam conflict caused the Liberty Powder Company to once again start up the bag manufacturing building to produce cloth bags for the 105mm artillery charges. 2 months later, Olin Matheson dissolved their subsidiary and took direct control of the plant's operation. This change occurred at the same time the igniter and propellant loading lines were reactivated and were using powder from other munitions manufacturers. This major reactivation, however, was not without problems. There were numerous issues of maladjusted sewing machines and scales, incomplete technical data packages, and fluctuating requirements. The problems were often solved through hiring former DuPont and Goodyear employees that were familiar with the equipment and operations. On August 1st, 1963, the military installation adopted another name change and became the Indiana Army Ammunition Plant. With the escalation of U.S. troops in Vietnam, production of the 81mm mortar charge at the plant rose in the late 1960s from 600 per month to 8 million in June of 1968. Olin was asked to reactivate a portion of the smokeless powder manufacturing area in 1969 as well.
When I hired in, I worked for Olin Matheson for almost 4.5 years. Then ICI got the contract, and I worked for them the rest of the time. It was ICI. We had 2 firehouses. We was the fire and the security, and we worked out of the firehouse. They were so safety conscious. That's part of my job was when people would come to work, they would come to the gate, and when they would first come in, we'd ask them if they had any matches or lighters. They couldn't bring any matches or lighters into the plant. Then they went back to the search alley. We asked them if they had any matches or lighters there. If they got caught there, they got a day off. Then they went from there, they went back to a change house, and they changed into their powder clothes, their work clothes, and they weren't allowed to have anything out of there. And if they got caught back there with cigarettes or lighters, it was a week off there. Then this is the first time, the first offense. And then if they got caught out in the explosive area, it was automatic 30 days off, and the second time was automatic dismissal. Everything was searched. We had ladies that searched the ladies, and men searched the men. And we'd go through, they'd have to open their lunch boxes up, they'd have to open their thermos bottles up and pour, if you wanted to make them pour it out in a cup, and make sure they wasn't bringing alcohol in or anything. You patted them down, you looked through their lunch boxes, you didn't touch their food or anything. Most of the guys I worked with when I first hired in there had worked there during Korea and stuff, and right at when World War II started, most of them got drafted anyway. But it was a lot different up there in World War II, because like I was talking about our searches in World War II, when they came into a change house, they went down to their underwear in the front, and then they went through a search. Then they went into their work clothes in the back. But we never did that. That was during World War II. And during World War II, they had tires down in the well areas and everything. They had it was even though I thought we had good security, but in World War II it was really strict down there. And what we call perimeter patrol, that was one that went completely around the property. And then we had IOW patrols. That was the ones checked up in the IOW end. We had HOP patrols. They checked on the HOP end. They had igloo patrols. They had to check the igloos. You had ship house patrol. They checked the ship houses. And it was just, I mean, the place was well covered. It was, all the igloos had to be checked at least once a day. Some of them had to be checked twice a day, depending on what kind of powder was in them. All the box houses that had powder in them, they had locks and seals on them. We had to record all the seals every 4 hours on most of them. And we did traffic. We did basically, it's like a police department on the outside. We ran radar, and we had fire inspection. We had fire drills, and we had 50 homes up there where the military lived, and we had a couple of those that caught on fire and burnt pretty bad, but we saved most of it. And
in 1978, construction of the $40 million, state-of-the-art, mostly automated black powder manufacturing facility was begun along 14 Mile Creek, within part of the Rocket Propellant Plant, or IOW number 2. Traditionally, the process of making black powder was very labor-intensive, requiring shoveling of sulfur, potassium nitrate, and charcoal into a wheel mill. The new facility was a computer-monitored system of conveyors and metering stations. It was designed to be operated by remote control, using state-of-the-art technology and computer systems, and could be operated by just 10 employees. With a projected monthly production rate of 500,000 pounds of Class 1 military-grade black powder, the facility went through its prove-out test in 1983 and was placed into standby status after just 1 month of operation.
The push for a new black powder plant began probably in the 60s when it was conceived, and some of the development work was in the early 70s, and then the actual plant started, construction and such, was in probably the late 70s. The reason for the black powder plant is that the old DuPont plant, DuPont got out of the business some years before, and the plant was still being operated by, and when all this started, it was operated by Gerhard Owens, and a company then came into the picture named GoEx. But they were still operating the old original DuPont black powder plant up in a town called Moosic, Pennsylvania. And they would have a blow once a year or so. They would have a major blow and kill a few people and knock out a part of the plant. And the other problem was that the town, the civilization was beginning to really encroach on this plant, so it was in danger of losing the plant altogether. The other thing was that the artillery and flares and different things that still consume black powder, the consumption was projected to go up dramatically, because some of the newer artillery charges used large amounts of black powder for ignition of the gun propellant, the stuff we were talking about earlier. So the projected usage was way up under a mobilization condition. Maybe the unfortunate part of the new black powder process is that it came also in a huge transition period of instrumentation and control technology development. So a lot of the ideas were great, a lot of the concepts for automation were great, but the hardware really hadn't caught up with the the intellectualizing of automation. So we had just huge problems with software and control hardware and instrumentation.
In 1972, the maintenance and production activities at the plant were taken over by the Imperial Chemical Industries Americas of Wilmington, Delaware. It was time to upgrade and modernize, and ICI had plans to do so.
Good morning, I'm Lieutenant Colonel Sanderson, the commander of the Indiana Army Ammunition Plant located in Charlestown, Indiana. We are a government-owned, contractor-operated plant in southeast Indiana. Our primary mission is to manufacture bag propellant charges. In other words, we get bulk propellant in from another government-owned, contractor-operated plant. We manufacture our bags here, and then we load those bags, containerize the finished charge, and ship them on to their final destination. Throughout this film, you will see some of the modernization effort that has been ongoing here at Indiana. Our additive liner building is one, and what that is, it's a wear reducing liner which we manufacture here at Indiana. Also, you will see our flash reducer and our CBI loading of the M119A1 prop charge down in our bag manufacturing area. And then in addition, you will also get a view at our new center core modernization line, which we are in the final steps of getting ready to start producing the M188 charge, 8-inch charge.
Going in the wax tank. Wax up through the top line over to the processor. Alright? When the processor is not calling for wax, the wax comes back into the tank, returning line. Each tank holds 310 gallons of wax. This might not go through, it's so stick. Come on around here. This photo cell here controls the cut of the length of the liner. It comes on through, it hits this eye. The liner is dropped on the scale to be weighed. The reject liners go in the reject. Make your reject. The good liners come over the belt, go on down into the stack. That's supposed to be a good one. You have to come to a thing like this. Falls into the stack. Right there. storage of M13 A2 charge containers, which supports the 155 white bag. A cradle like this holds 95. As you can see, we can stack 2 high in the warehouse. We can maintain, if you pan over to the left, we can maintain 5 aisles, which we could not do with the loose storage. It only takes 1 forklift operator to store the cans in this fashion. Same way when we get ready to load it out, again, it only takes 1 forklift operator. We can either load or unload a load of these in about 12 minutes time. Compared to loose, it would have taken about 3 to 3.5 hours to either load or unload a load of those containers. A lot of other side advantages is that the cans come in from the vendor in this particular cradle. They don't get handled again until they go on the line, the telescope conveyor at the end of the line. So therefore you avoid 5 individual manual handlings of that container. Doesn't get dented up, doesn't get scratched up. You get a lot better quality can on the load line. It's also aided in avoiding rust of the charge containers, because as you can see, we've got now where the cans used to be stacked the full range of the warehouse. You had them about 1 inch off the floor, and you would get accumulation of moisture from the concrete. You pretty much eliminated that by giving yourself an airspace between, below, and above the containers. So we're not having near the problem with rust where a can stays in the warehouse for maybe 3 to 6 months. Before, we were having a problem with the moisture buildup. When the outside temperature would change, this floor would sweat and the cans would actually go through a sweat. Well, now they do to some degree, but we get a lot less of that. If there is any little place where there's a tiny little nick or whatever, it doesn't rust nearly as quick as it used to. The other advantage to that is when this can goes to the load line, it gets the charge containers taken out of it, it comes right back to this warehouse in an empty trailer. All we have to do is simply put an empty cradle on the commercial trailer. It goes over to our container vendor, gets reloaded, and it comes back. It's a continuous cycle. We've been able to reduce our manning from about 37 down to 14. As a result of using that, we feel like we're doing it much safer. We don't have the people up on the stacks like they used to be in the warehouse. We don't have the pinch points. We don't have the mashed fingers, the bruised toes and feet where they would let a can slip out of their hand. Just all the way around, it's been an excellent thing, and it's saving about $450,000 approximately a year in just handling costs. Nothing to do, not even considering any quality improvements or anything like that.
When the Indiana Army ammunition plant was complete, it covered 10,655 acres. More than 50,000 people were employed at one point, and the economic impact to southern Indiana can never fully be calculated. The actual cost of the plant totaled $133.4 million, and in 1989, the U.S. Army placed a $1.9 billion replacement value on the property. After nearly a decade of steady production of propellant charges, the Army began reducing its stockpiles, and production orders had reduced by 1989. Once again, layoffs were coming. The up and down employment cycle of the powder plant never stayed up for too long. Employment at the plant was cut by another 565 jobs in April, reducing the payroll to just over 1,100. And then, all powder production and charge manufacture activity at the plant ceased in 1992. The Indiana Army ammunition plant was officially placed in inactive caretaker status for the last time. In 1995, the plant was renamed Facility 1 and converted to a private use industrial park. Working with local and state governments, economic developing agencies, Facility 1 sought to direct potential commercial tenants to the plant, providing a host of amenities and almost 8,000 acres of industrial park. The goal was financial investment and job creation for southern Indiana. They offered heavy and light industrial, warehouse, distribution, office and administration, chemical manufacturing, and storage were all possibilities on the restructured plant property. By 1996, several thousand acres had been deeded over to the state of Indiana to become Charlestown State Park. The Clark County Board of Commissioners created the INAAP Reuse Authority in 1998 to plan the redevelopment of the industrial areas. In 2004, the Reuse Authority changed their name to the River Ridge Development Authority, and they continue development of the River Ridge Commerce Center. An additional 3,000 acres is being added to the state park, and residents of Charlestown and southern Indiana once again have extended public access to the Ohio River. With industrial development in the private sector, a resurgence of growth once again molds the plant's landscape. As the old power plant towers stand as watchful sentinels over the aging buildings, the sounds of construction once again announce yet another chapter to the Indiana Ordnance Works in southern Indiana.